Okay, Collins, Maths Frameworking, book 3.3. So, chapter 10.3, Composite Shapes. So we've been doing volumes of cylinders, surface area of cylinders, and now we're doing this kind of composite shape with two cylinders on top of each other. I've already drawn it. So let's do the volume. So what I'm going to do, first of all, is I'm going to name these A and B. So the volume equals the volume of A plus the volume of B. Now this is important to kind of give them little names. You can call them what you like. You can give them Greek letters, alpha, beta, gamma, or X and Y, or whatever. But we've got more than one radius and we've got more than one height. So we can't just use our normal formulas of pi r squared h and then have another pi r squared h. We've got to use our little subscripts. So the volume of A is pi r A squared h A plus pi r B squared h B. So whenever we refer to a radius or a height, we know whether we're talking about the A or the B. So this is the volume of A, pi r squared h, but the r is the radius of A, it's the height of A. And this is pi r squared h, but referring to B, so it's the radius of B, it's the height of B. And then we can pop the numbers in. Make sure your equal signs are lined up. So that's pi times, that's diameter. That symbol there means diameter, by the way. So the diameter of A is 4, the diameter of B is 10. But we need radius, so 2 squared times 5 plus pi times 5 squared times 8 equals, does it tell us to keep it in pi or, okay, it does actually eventually put it into real numbers. But to start with, let's keep it in terms of pi. 2 squared is 4, 4 times 5 is 20, so that's 20 pi, plus 5 squared is 25, 25 times 8 is 200, 200 pi. Can you see how it's a lot easier just keeping pi as pi? 220 pi, okay? And then we can figure out what that is. You know, you can do that. 220, so in the book, sure enough, 220 pi, and you can calculate that to be whatever that is, centimeters cubed. Don't forget the units. Now we're going to do the surface area. I want my picture. So, but we're going to need a lot of space. So the area, this is going to be tricky. Now what we're going to be careful of here is that some areas, this is one shape, it's not two, we can split it up into two shapes to help us with the maths, but it is one shape, okay? If we're going to paint it, we're not going to paint where this is joined to this. It is one piece. We can't get in there to paint it, for example. So the area is, we need the, so we've got this circle here. So, okay, so let's call this curved surface A. Let's call that curved surface B. And let's have some other letters, X, Y, and Z is that bottom surface. So we've got the very bottom, we've got this platform here, we've got the very top, those three surfaces, and we've got this curved surface, and we've got this curved surface. So 5 surfaces, X, Y, Z, A, and B. Okay, that will help us out. It's the area of X
plus the area of Y plus the area of Z plus the area of A plus the area of B.
So we've got these 5 different areas that we need to add up. Area of X equals pi r x squared, which is pi times 2 squared, which is 4 pi. Okay, done. The area of y, let's do the area of y. That's this one. So that's, hang on. We'll leave that for the moment. Let's do area of z. So the area of z is just a circle. So that's pi r z squared. Pi times 5 squared equals 25 pi. Okay, so the area of y here, you see that? Yeah, I can still see that. The area of this is the whole circle, same as that one. Take away this small circle, isn't it? Because it's like a donut shape. So it's going to be the area of z minus the area of x, which we've already got. So 25 pi minus 4 pi equals 21 pi. You can see how keeping pi in there is super useful. Okay, let me just highlight some of these now for the moment. So we've got that one there, we've got this one here, we've got this one here. Now the area of the flattened out surfaces, so the area of A equals the circumference of A, which is pi d. I'm going to put that number straight in. Pi times 4, pi d, that's that, times the height here, times 5. That's 20 pi. And then the area of B. So that's the circumference here, which is pi d. Pi times 10. And then times the height, times that, times 8. 80 pi. Woo-hoo-hoo. So you can see why writing formulas out can really help you now. So now we need to add these all up. We have 80 plus 20 is 100. 4 plus 21 is 25. That's 125, 150. Area total equals 150 pi centimeters squared. Don't forget those units. 150 pi, which they've calculated. You can do that if you want to, times it by pi and find out the number. Bloomin' heck, that was 9 minutes for one example. There is another example here. I will do it. It's going to be a long video. Apologies. Perhaps have a go. We're now going to do a tube. Video got cut off there. So 10.3, the second example. So it's a tube or a cylinder with a hole through it. I'll just draw that here. Like that. And we've got the outside radius and the inside radius. That's 3 centimeters, and to the inside is 2 centimeters, and the height or the length of the tube is 6 centimeters. And we've been asked to work out the volume. The volume, just 3 significant figures. Okay, so the volume is basically the volume of the outside diameter, the big cylinder, minus the hole, so the volume of the inside. Okay, volume is pi r squared h, pi r squared h, but let's put r o for the outside, minus pi r squared h, but this is r I. So it must be clear which the two different r's. H is the same, because obviously these are the outside and the inside. It has the same height. Okay, 2 different ways of doing this. I can put those numbers straight in. Equals pi times 3 squared times 6 minus pi times 2 squared times 6 equals 3 times 3 is 9. 6 times 9 is 54. 54 pi minus 2 times 2 is 4 times 6. 24 pi equals 30 pi centimeters cubed. And yes, you can work that out to 3 significant figures if you have a calculator. I don't have my calculator, left it at school, and all the phones are being used for FaceTiming friends by the kids. But let me just kind of stop like that there. Let's pick it up from there and see what else we could do. Because do you notice how there is pi in both of them, and there is h in both of them? It's the same h, and obviously pi is the same. So I'm going to kind of carry that on. So I'm going to say pi times 6. And then in brackets, I'm going to put RO squared minus RI squared. So the outside radius 3 squared minus the inside radius squared 2 squared. So basically, I've got 6 pi, then times this. So let's do that. 3 squared. So 6 pi times 3 squared is 9, 2 squared is 4. Sorry, where am I? What? That's 9, take away 4, it's 5. Sorry. It's 30 pi. 6 times 5, 30 pi. So exactly the same. And yes, like I say, we could times that by pi and get the answer there. Great.